I'm going to show you how to draw the Lewis structure of hydrogen cyanide, which is HCN. First, you're going to need to figure out the valence electrons of each of these atoms using the periodic table. So hydrogen would be 1, carbon would be 4 valence electrons, and nitrogen would be 5. Next step you need to do is add those all up together to figure out how many total are in the molecule. So it'd be 10 altogether. And what you're going to need to do is find out the middle atom, which is carbon in this instance. So you're going to want to draw a carbon in the middle of these two atoms and draw a bond of hydrogen on one side like this, because hydrogen can only have one bond because it only has one valence electron. Next step you're going to need to do is draw another single bond connected to nitrogen like that, and look at how many atoms you have left and figure out the octet rule, which is the atoms have to have 8 atoms within the molecule together to be a-okay, and carbon likes to have 4 bonds connected to it. So because of that, and to obey the octet rule, you draw 2 more bonds, making a triple bond with nitrogen, and nitrogen has a lone pair to give it the 5 valence electrons that it needs. So the final product would be that. And to show you a 3D model of this, I have it right here. So I'm using gummies and chopsticks as the atom. This would be the triple bond in between carbon and nitrogen, and this would be the single bond between carbon and hydrogen. And to explain the electron pair geometry and the ideal bond pairs, using what I just showed you there, since it is just a linear molecule, it would be a linear electron pair geometry. And the ideal bond angle between that is 180 degrees because of a straight line. And to explain why it is a polar molecule, that is because the carbon-nitrogen bond is a stronger pull on itself than the hydrogen and carbon bond does. So it has a stronger pull on one side than the other, making it a polar molecule and not a non-polar molecule, which is equal pull on both sides.